In this chapter, we will be studying systems of equations and inequalities. In this lesson, we will be studying quadratic inequalities in one variable.
Okay, hi everybody. So today we're going to take a look at quadratic inequalities in one variable. Now, you would think that really we're taking a step backwards because in a previous lesson we looked at what quadratic inequalities in two variables look like. Shouldn't one variable be a bit easier? No, actually in this particular case here, this is a little bit more complicated of an idea. Now I like what we're doing in this workbook here that I'm working with that a colleague of mine has put together. But there's some stuff here that really needs some clarification. You really need to focus on what we're saying. It is very easy to get through this and to move a few steps down and then to think you're understanding it correctly and very quickly revert back to a mistake in understanding. So, and I'll show you what we mean by this in just a second. So recall from lesson 3, this is a couple lessons ago, that inequalities in one variable involve a number line and x values only. Okay? Yeah, x values only. So when we say that x is greater than or equal to -2, you circled the -2 and we pointed the arrow to the right. Okay? So this is that set of values that satisfy this inequality. X is greater than or equal to -2. Wonderful. Now, this inequality, though, is also an inequality of a linear function. If I bring that -2 over to the other side, if I add that -2 to both sides, I am going to get this new inequality. X plus 2 is greater than or equal to 0. These are stating the exact same thing. Okay? The exact same thing. But when you write it like this, okay, you should recognize, hey, you know what? I've seen stuff like x plus 2 in a slightly different context. Okay? I have seen it look, wrong way. I have seen it look like this. Y is equal to x plus 2. You know, that's like a linear function. And I want you to think about what this is saying here, because this gets confused so often. Sometimes we look at this, and it is screaming at you a very specific relationship, and sometimes it's so easy to gloss right over it. Every point on this line, everybody, has the coordinates x comma y. But we can do better than that. In fact, if I was just to say plot the point x comma y on a grid, a Cartesian plane, well, you wouldn't know what to do. You just put it, you'd put the points wherever. You wouldn't have a clue. So how do we guarantee that I'm picking a point that's on this line? Well, there is a relationship here. The y depends on x. How does y depend on x? It's x plus 2. So the coordinates of every point on this line would be x comma x plus 2. This right here is the formula for creating the y coordinate. This is, okay, I'm going to say it again. This is the formula for creating the y coordinate. Okay, the corresponding y coordinate. So now let's back this up a little bit. So what does that mean? Well, if I go back to this, in essence, I'm almost starting to extend this idea into 2 dimensions. Okay, almost. There's going to be some kind of give and take here. But this is like saying, I'm asking everybody where my y coordinate is greater than or equal to 0. That's what that is, because remember, this is how I generate the y coordinate of this particular graph. So maybe what I'm asking for is, where does that line, y equal x plus 2, where is that line greater than 0? Now all of a sudden, I'm switching this to sort of an interpretation in 2 dimensions here. So here's what we mean by that. Here is the line, right here. This is the line y equals x plus 2. This represents all the points where the y coordinate is 2 more than the x coordinate. I was just asking, okay, where is x plus 2 greater than or equal to 0? Now bear in mind what that means. I know that this is a way of getting the y coordinate. So I'm asking, where is y greater than or equal to 0? Well, that involves thinking this way, and all of a sudden, this is where I know people are going to start to get confused. I am not asking you to read this left to right. I'm asking you to read this up and down. Where along this line are my y coordinates greater than or equal to 0? The y coordinates are greater than or equal to 0. That occurs, here's where I stop. This line right here represents the boundary. Everything below this line, okay, everything below the x-axis, my y coordinates are negative. They're less than 0. Everything above this line, my y coordinates are positive. So I'm asking everybody, where is this line? Where are the y coordinates greater than or equal to 0? Well, I stop right here. Basically, I'm going to cancel out all of this. This is all irrelevant. Now, so look at what I'm left over with. Look at this. This is where the y coordinates are positive, or greater than or equal to 0. Now, bear in mind though, this was not how the question was asked. It was asked like this. So when I ask you, where is x plus 2 greater than or equal to 0? I have to answer in terms of x. Now, and I know this is where things get a little bit weird. I am graphing this as if, as if it's the y that I'm interested in, where y is greater than 0, but I have to answer in terms of x. Now, so ignoring this part down here, notice that this x plus 2 goes to 0 when x is negative 2, and then for all values of x to the right of that, the line is above the x-axis. So from this point on, all of my values are above the x-axis. This is where, from this point, negative 2 on to the right, that's where all of the y coordinates extend above the x-axis. And so this is just another way of interpreting this. Now, in this particular context, this is far more difficult. Okay, it's much easier just to see this problem in this way and just say, okay, well, x is greater than or equal to negative 2. I graph it like that. The reason we bring it up like this is because in this next context here, when we start to work with quadratics, once you get used to what's going on here, this is a much easier way of answering the problem. Okay, right now this is probably more difficult, but in a little bit this will be a much easier method here. So when working with quadratic inequalities, this little line says down here, instead of stating the x-intercepts as the solution, the graph is used to identify the intervals along the x of the x values, intervals of the x values. So focus on that. We're going to give the answer. Your solution will be intervals of the x values where the y values are either above or below the x-axis. So it's like in this question right here, I'm walking along the x-axis here and I'm looking for the function. From negative infinity up to negative 2, I had to look down to see the function. But from negative 2 on, I had to look up. And then the question was asking, where is the y? Where do I have to look up to see the function? Okay, let's take a quick look at quadratics now. Let's see if we can make sense of this. So a quadratic inequality in one variable can be written in one of 4 forms. Therefore, there are 4 possible scenarios where the quadratic inequalities can be interpreted here. Now, we are going to use two-dimensional graphs with the y. But please understand that when these questions are asked, there is no y. Okay, there's no y at all given. We are using the graph to link it to the answer here. So just like over here, where the question was asked, where is x plus 2 greater than or equal to 0? Well, that was the same as this answer right here, which is stating the same thing as this right here. I'm just representing this in 2 dimensions. I'm calling this y and graphing it. Okay? But the answers ended up being the same, negative 2 on. I'm assuming that's going to be true over here. So I'm looking at the graph of a quadratic right now. Now, let's zoom in. Whoops, wrong way. Let's zoom in on the expression here. I'm looking for where my function of x is greater than 0. So here's my parabola, here's my f of x. I don't even want to state what it is right now. I don't want you to get confused with actual numbers in there. We just want to focus on the parabola. I'm asking, where is this parabola greater than 0? So here's my parabola. And notice that it hits 0, because remember, f of x is the same as y. So it becomes 0 when x is 1 or x is 5. And then if I go out from those, that's where the parabola is larger than 0. That's where the parabola is above. So f of x, this is a function, this is a way of calculating the y-coordinates. The result, the y-coordinates, are going to be positive when the x values are either less than 1 or greater than 5. Okay? So the solution is the set of values for which of x for which the graph is above the x-axis. That's what we mean by greater than 0. Okay? That is your greater than 0. F of x. Now, the solution set does, in this case, does not include the x-intercepts. That's why we put these little empty circles in there. But notice how our answer works here. It's empty circle along the x-axis, empty circle along the x-axis. We're really only using that number line to give us our solution. And so our solution set here is going to be where x is less than 1 or x is greater than 5. Now, if you really want to look super intelligent when you give this answer here, you'd say x is less than 1 union x is greater than 5. It means the exact same thing, it just looks cooler. Other scenario here, where f of x is greater than or equal to 0. Now, in this case right here, the only difference here is going to be that we're going to include those x-intercepts. So we have already found that the x-intercepts here were at 1 and 5. Because of the or equal to, we're going to include those two values here. Now my answer, and I'm just going to kind of jump right to the conclusion of where this is going here. The answer that I'm looking for is either going to be between those two x-intercepts or outside. The parabola that f of x represents looks like this. Okay? So there's this boundary here at 1, there's this boundary here at 5. I've got 3 different intervals. This right here is the interval where x is less than 1. This is x is between 1 and 5. And this is out here where x is greater than 5. There's 3 intervals because of the x-intercepts. Now, is the parabola above the x-axis here? Ignore everything else. Is it above the x-axis? Yes. Awesome. Look in between. Is the parabola above the x-axis? No. Not here. Is the parabola above the x-axis? Yes. So my answer is going to be either x values have to be less than 1 or x values have to be greater than 5, and because of the or equal to, we will include those. Now I should have probably included those in there too. But my answer is going to be this interval and this interval, or I should say, or this interval. And again, you could put the union symbol there if you'd like to make it look cool. The alternate way of looking at that is we've got our parabola here, and I want to know where the parabola is less than 0. So again, our focus is on the number line here. We know that it's going to hit this parabola. Even without giving you the equation, I can see from my graph here that I'm hitting the x-axis at 1 and 5. So I put these open circles there at 1 and 5. I want to know where the parabola is less than 0. Now, remember 1 and 5 split this thing up into 3 intervals. X is less than 1, between 1 and 5, whoops, x is greater than 5. My parabola looks like this. Now, my question is, where is the parabola, the y-coordinates, less than 0? Again, when it's f of x, this represents the y. Think back to Math 10 when we're introduced to function notation. That means y. Where is y less than 0? So let's look to the left of that first intercept. Is y less than 0? Are the y values of this line below this line right here? No. In between, are the y values less than 0? Yes. Over here, are the y values less than 0? No. So the answer I'm looking for is this answer in between those two. And so we would answer our question like this. So f of x lies below the x-axis. The solution set does not include the x-intercepts, and so we are going to say that it's the set of all x values where 1 is less than x is less than 5. Okay? If you attach this last little stipulation here that we are looking for, and this should have been f of x less than or equal to 0. So we're still looking for below 0. Then what we would do here is on that number line, those two open circles we had at 1 and 5, we would fill in. And again, we recognize that that parabola is below the x-axis in between those two. And so our solution set in this case would be 1 is less than or equal to x less than or equal to 5. Now before I leave this, I do want to go back and just mention really quickly, to answer these questions, you could have used interval notation as well. And you would have seen this earlier here. Another way of writing this is your set builder notation. We also could have gone from negative infinity up to 1, not including 1, and then union 5 out to infinity. Okay, remember, I hope you remember that. Remember, when we use parentheses here, we mean that we're not including those endpoints. Here, this would look like this: negative infinity up to 1. We use the square bracket there to include the 1. And then 5, again with square brackets, out to infinity. Here, to show the interval in between, because we're not including the endpoints, I would simply write that as 1, 5 with parentheses. Now that looks like the coordinates of a point. You're supposed to know that in context, that does not refer to a point. That refers to an interval. And then down here, when we're including those endpoints, we'll put 1 and 5, and again with square brackets to indicate that we're including those. So just another way of writing those intervals. I really hope it makes sense what we're trying to accomplish here. The two-dimensional graph that we're drawing is merely a tool to help you see, okay, where that relationship produces values that are greater than 0 or below 0. I'm looking for the entire, after the calculations are all done. I'm not asking where x is positive, I'm not asking where x is negative. I'm saying that after you do a bunch of calculations on x, the result, where is the result greater than 0 or less than 0? For what values of x do you plug in and the result is greater than 0 or less than 0? So for example right here, if you plug in values of x into this parabola less than 1, the result's always positive. Okay, it gets quite big. If you go between 1 and 5, the results are negative. And from 5 on to infinity, you're going to get positive results. It's like looking at the table of values and just noticing, at this little chunk right here, whenever x is these values, I'm getting negative for my y coordinates. Okay, I hope that's clear. Let's just take a quick look, okay, at one more little example here, and hopefully this will help even more. Let's say we've got this other parabola right here. Okay, so again, what's going on here is we're not giving you the equation per se. All we're telling you here is that this is some function of x, some equation here. The solid line that they've got written here indicates where the parabola here is above the x-axis, which means whatever the function is, whatever the machine is that's crunching away with the x values, when you plug in the x out here, okay, out here and here, the results are going to be positive. In between, the results are going to be negative. So remember, those x-intercepts break this thing up. So in this particular case right here, this interval that I've drawn this dotted line to go straight through that x-intercept. This is where x is less than negative 2. This is between negative 2 and 2. Whoops, can't see that. Out here, this is where x is greater than 2. So if my question is asking where is the function f of x, where is that relationship there greater than or equal to 0, I'm looking at the x-axis here. This is the intercepts here where I hit 0, and if I go out, my result is greater than 0. So if I go out, the result is greater than 0. So that's why my answer looks like this. Or if you want to write it in interval notation, negative infinity up to negative 2, and then 2 out to infinity with square brackets on the negative 2 and 2. If I'm interested, though, in where the function is less than 0, not including the endpoints, bear in mind that's now this part in between. That's where the parabola is producing negative y coordinates. Okay? I'm seeing that's where it's positive. I'm seeing that's where it's negative. I'm not asking for the information about it two-dimensionally, though. I'm simply asking where along the number line are the results above or below. So down here, again, the answer is going to be between negative 2 and 2. And if we write that in interval notation, negative 2 out to 2. Okay, maybe we should just take a look at some examples that don't have the rest of this material in it, and I'll lead you through, and hopefully you'll be able to make sense of where we're going with that.
Now we'll look at solving quadratic inequalities graphically.
Okay, so before we get into specific questions here, there are a few different ways that we could go about solving these quadratic inequalities. Our first method is graphically. Now I'm starting with this one, and I really think this is the one that you want to be doing. Okay, so this is the one that I would emphasize. So what you want to do with this right here, when you're given a quadratic inequality here, first of all, you want to determine what the x-intercepts of the parabola are. Really, really important that you know what the x-intercepts of the parabola are, because those are going to be the boundaries between when you're positive or negative. Okay, I'm essentially asking a similar sort of question, like, when are you in the room? When are you out of the room? It's important to know where the door is to get from inside the room to outside the room, or vice versa. You have to go through the door. In order to go from above to below the x-axis, or vice versa, you have to go through the x-axis. Those are your x-intercepts. It's also important to determine the direction of the opening, whether the parabola goes up or down. Now I'm going to show you with another method here how you can kind of get around that a little bit. But if you're going to plot these things kind of by hand, man, it's important to know whether it opens up or down. If you get that wrong, then your answer is going to be completely opposite what the intended answer is supposed to be. Then you're going to write down the solution with the correct symbols and express it on the number line, or express it on the number line. We might ask you to do it one way or the other. Okay? So yeah, let's just get in and do a couple examples here, and hopefully this will start to make a bunch of sense. Okay, so now for this first question here, we're going to base it on the graph of y equals x squared plus x minus 2. Okay, now before we look at the graph here, what we might do with this is factor it to find the x-intercepts here. So that's going to be x plus 2, x minus 1. So I'm going to get intercepts here at negative 2 and positive 1. And I know that this parabola opens up. So this is a fairly good representation of that. There's positive 1, there's negative 2. Now, notice I'm not concerned about the vertex. In a lot of previous chapters, the vertex played a significant role here, but I'm really not interested in that. I just want to know, where is it above the x-axis, where is it below, and that has more to do with the x-intercepts than it does the vertex. So now, my first question is going to be, where is this parabola, where is this f of x, this whole machine here, greater than 0? Okay, well here's my f of x, and I'm going to look at those x-intercepts right there, and I know that those x-intercepts are going to break this apart into 3 different intervals. Okay, I have got the interval where x is less than negative 2. I have got the interval between negative 2 and 1, and where x is greater than 1. Okay, I'm looking for where this parabola, this first question is where it's greater than 0. Okay, there's my 0 line. So it's out here and out here. That is where x is less than negative 2 or where x is greater than 1. Okay, so there's my answer. X is less than negative 2. Now I could put the word or a comma, but I like putting the union symbol where x is greater than 1. Now not or equal to, because the question isn't including those. So I would leave it like that. This next question is asking me, where is this function less than or equal to 0? Okay, so in this case right here, less than 0 means, again, I cover up the top half, I'm looking for this. So the parabola is the part that I'm looking for is in between these two lines. That's this interval right here. So -2 less than x less than 1. But in this case, because of the or equal to here, I will include those endpoints as well. So essentially what that is just like shading that in. Next, x squared plus x minus 2 less than 0. Okay, well the previous question was also less than 0. So this is going to be the same structure of, whoops, I don't know why I put the negative behind it. That was really weird. But in this case here, I'm not going to include the endpoints of those intervals. Okay, I just leave those off here. So -2 is less than x is less than 1. Awesome. This one right here, x squared plus x minus 2, that is very similar to this one up here, except now I'm including the endpoints. So this is going to be the same as x less than -2 or equal to union x greater than or equal to 1. So there's my solutions based on this particular graph. Let's take a look at another one. Okay, now this one's slightly different. This one has been designed to kind of play with you a little bit. So this graph right here, we can see when we plot this, has an x-intercept here at 2. Now, here I put a line through there at 2. That breaks me up into a couple of intervals here, x less than 2, x greater than 2. Now, because I've only got 2 intervals here, this is starting to feel a little weird. I would feel better if I had 3 different intervals here with 2 x-intercepts breaking it up into 3. This feels a little weird. So now I'm going to take a quick look at my question here. I'm being asked, where is this function greater than 0? Where is this function greater than 0? So I'm going to cover up the stuff below 0, below the x-axis. Where is it greater than 0? Now, don't feel weird about this and start grasping at answers that don't exist. There is no graph greater than 0 here. There is no graph. I don't see anything here. There's no solution to this question. None. Now, where is this graph less than 0? Okay, let's go over here. Let's cover this up here. Well, there it is. There's the whole graph. Oh, except for one little thing. I'm not including the 0. This particular question here is saying where is it less than 0, not where is it less than or equal to 0. So yeah, I get to see the whole graph, but I actually have to cover up that x-axis a little bit, which means I cover up that little hole. Which means really I'm using x is less than 2, x is greater than 2. So I might answer my question like this. X is less than 2, union, x is greater than 2. Now somebody out there is gonna ask, well, wait a minute. Couldn't I have written that and just said x can't equal 2? And yeah, you could do that. That's totally fine. Means exactly the same thing. It's just 2 different ways of representing the same thing. Now let's take a look at this one. -x squared plus 4x minus 4 is greater than or equal to 0. Well, we've already gone through this where we covered up and we saw that there was no graph above the x-axis. But if I just let myself see the x-axis, because this is or equal to, I notice that there is a dot right there. Now, there's nothing else, just that dot, just that one number. So this is kind of weird. And maybe it would be better for me if I put it in a set notation, but it's just the number 2. That's it. Kind of a weird answer. But when x is equal to 2, that's the only place that satisfies this particular inequation. It's only because of the or equal to 0. When you plug 2 into that equation, it becomes 0. Now, this last one, where is -x squared plus 4x minus 4 less than or equal to 0? Now remember, we're covering up the stuff above it, but now we're letting ourselves see the x-axis. And now I'm seeing the whole thing. And I know this extends from left to right forever, so this is actually going to be all reals. X is an element of the reals. There we go. Okay, I hope that makes sense. Now, let's take a quick look at another problem here. This time we're going to kind of take the gift of the graph away and we're going to focus on being able to do this all ourselves here. So find the solution to the following inequalities. And we're going to answer it as a statement and on a number line here. Okay, so let's take a look at this one right here. Negative 2x squared plus 12x plus 14 greater than 0. Not given a graph. Awesome. Okay, so I gotta use my wits to figure this out here. So first of all, I'm going to factor out that negative 2. And I'll turn that into x squared minus 6x minus 7. I do that because I'm lazy. Okay? I do that because I'm lazy, and when I do my factoring to find my x-intercepts, I want that to be a little simpler. So negative 2, and that's going to be x, and my factors of 7 that add to negative 6 will be negative 7 plus 1. So my x-intercepts here will occur at negative 1 and positive 7. Fabulous. So negative 1, positive 7. And in this particular case here, I've been given a number line, so I'm going to throw my, all of a sudden I realized I probably should have done this better. Negative 1, positive 7. And I'm putting open circles on there because this is a greater than, not an or equal to. So not or equal to, not or equal to. Now, because of the negative leading coefficient here, I know that this parabola is going to look like this when I graph it. Okay? I don't know how far up it goes. I don't need to know how far up it goes. All I need to know is that it's up here and down here. This is going to break my graph into those 3 intervals that I love so much. X less than negative 1, negative 1 less than x less than 7, x greater than 7. Those are my, whoops, you can't see that. Those are my 3 intervals right there that those 2 intercepts break up the x-axis into. I want to know where that function is greater than 0, which means I am going to cover up the denominator. Oh, denominator, wow. I cannot believe I just said that. I'm going to cover up the part that's below the x-axis. Oh boy, that is not called the denominator, don't do that. Now, that occurs in that interval in between. So this is going to be from negative 1 to 7. So there's my answer. Negative 1 is less than x, which is at the same time less than 7. On the graph, I would connect it like that. And if I wanted to use interval notation, I would do this. Negative 1 out to 7. Okay, with parentheses around the negative 1 and the 7. Okay, perfect. Try this one over here. All right, once again, there's a negative in front. Now, I'm going to take out the negative again because it's easier to factor these things. Okay, it's easier to factor these things if the leading coefficient is positive. I'm going to factor because, again, I'm looking for the x-intercepts. Factors of negative 12 that add to negative 4, that'll be negative 6, positive 2. And so x is either going to equal positive 6 or negative 2. Now this is an or equal to. So I'm going to plot those, and that's going to be negative 2, positive 6. Down here on the number line that I've been given, negative 2 filled in, positive 6 filled in. On this graph here, which is based, by the way, this is just, again, just a tool to help me with the one below, I'm going to put lines through my x-intercepts. And because of that negative right there, again, I know that this thing is going to open down. So it's going to be something like that. Whatever, I don't know. Great. Now, go back to the original question. I want to know, where is this parabola less than 0? Okay, so I cover that up. Okay, now less than or equal to 0. So I can see the x-axis, and I can see my intercepts there, and they're out here. So notice, it's not this middle section, it's these out here. I didn't write those out this time, but I'm hoping you're seeing that that is x less than negative 2. Out here, x is greater than 6. It's this negative 2 to 6. I'm not using that part right here. I'm just using these outside parts here. And because of the or equal to in the question, I would include the negative 2 and the 6 here. So for my answer, I will shade outside the x-intercepts, okay? And then when I write my answer in that set builder notation, it would be x is less than or equal to negative 2, union x is greater than or equal to 6. And I could also write that in my interval notation, negative infinity up to negative 2, square bracket, 6 out to infinity, and again, square bracket on the 6 there. Okay, we're gonna do one more here. Then we're gonna take a look at a different method. But here, before I can answer this question, I really need that inequality to be expressed with respect to 0. Okay, so that I can relate that back to the x-axis here. So x squared minus 5x minus 14 greater than or equal to 0. I am going to factor that. So x minus 7, x plus 2. So my x-intercepts here will be positive 7 and negative 2, so it'll look something like this. Because of it being or equal to, I would fill those in, those circles that I have on 2 and 7. I am going to put my little lines through there to create those intervals that I've been doing. So x is less than negative 2, negative 2 is less than x less than 7, x is greater than 7. These are the names that we would give to these intervals. And then now, just because I've started this up here, I'm going to put my circle around the negative 2, fill it in, my circle around the 7, fill it in. I will come back to this solution in just a moment. This parabola has a positive leading coefficient, so it's going to open up. I am interested in where this parabola is greater than or equal to 0, which means I am going to cover up everything that's below. And when I look at what I'm seeing right now, I'm seeing this interval and this interval. That's where my line is drawn. So that means x is less than negative 2 or x is greater than 7. So there's my solution. X is less than negative 2, union, x is greater than 7. This isn't quite right yet though, not until I put the or equal to. And again, I get that because the question has the or equal to in it. So that's why I'm writing it out like that. That implies this and this interval on the x-axis, less than negative 2, greater than 7. And again, we might write this in interval notation as negative infinity out to negative 2, union 7 out to infinity, with what we call hard brackets on the negative 2 and the 7 to show that we're including them. Okay, good.
In this next section, we'll focus on an algebraic solution to quadratic inequalities.
Okay, well, another way to solve these quadratic inequalities in one variable is algebraically with a test line here. What we're going to do here is we're going to make use of the fact that these quadratic expressions that we're working with, or quadratic inequalities, quadratics are based on two factors multiplied together. Now, you can determine the behavior of a whole function by looking at how the individual pieces behave and then interpret how they would behave together. Okay? So we split this up here. So when we factor a quadratic, you get two factors. And what I mean by that is, like in the previous question that we just did here, we had x squared minus 5x minus 14. Remember that we just wrote that as x minus 7, x plus 2. Now, the behavior of this whole expression will depend on how x minus 7 behaves and x plus 2 behaves along the x-axis. Okay? So whether or not this factor right here is positive or negative will have an impact on whether this whole function is positive or negative. And here's how that works. If both of those factors are positive at the same time, so you plug in a value of x and it produces a positive here, then the whole thing is positive. If both of them are negative, then once again, the whole thing is positive because a negative multiplied by a negative is positive. But if you run into a situation where a value of x goes in, produces a positive in one place and produces a negative in the other, then the overall value here is going to end up being negative. And same thing if you do that in the different order, it's going to be negative here. So the trick to analyzing it in this way here is you're going to factor and find the x-intercepts, and you're going to put those on the number line. Then what we're going to do is we're going to choose x values that create the sign that we're interested in. Okay? Whether or not that factor is going to be positive or negative, we're going to determine the signs for those factors and then put those together to get the sign of the overall function. Let's go through some examples, and I think that'll start to make sense in a bit. All right, so we're going to answer this inequality right here, this x squared minus 2x minus 3 less than or equal to 0. We're going to answer this guy. We're going to do it using this method that we've just introduced here. We're going to take our time doing it. We're looking for where this is less than or equal to 0. So the very first thing we're going to do here is factor this, figure out its x-intercepts. So we get x plus 1, x minus 3 equal to 0, which means that our x-intercepts are going to be negative 1 and positive 3. Okay? So we've got that in our heads here. It might help us, again, to remember these factors. X plus 1, x minus 3 are the factors of this inequality. Now, once we've got the two x-intercepts, what we're going to do is we're going to put those x-intercepts on the number line. So negative 1, and just like I did before, we're going to put these lines through here, negative 1 and 3. That splits up the number line into the interval where x is less than negative 1, between negative 1 and 3, and where x is greater than 3. Now, the next part here can be done in one of two ways. Okay, and it is what it is. Okay, one of two ways here. You could, as is suggested here, start to choose test values, okay, and plug them in. So, for example, if you choose negative 2 as a test value, if you plug negative 2 into your two factors, and let's remember what our two factors were, okay, the two factors here were x plus 1, x minus 3. If you plug negative 2 into that, negative 2 plus 1 is going to get us a negative number. Okay, that's going to be a negative. I'll make that bigger there. Negative 2 minus 3 is going to also get us a negative. So the number negative 2 for these two factors here produce a negative and a negative. Together, they multiply out to become a positive. So the whole function is going to be positive in this interval. Let's choose a number between negative 1 and 3, and let's be lazy, let's choose 0. If you plug that in, 0 plus 1 is going to be positive right there, a value. 0 minus 3 is going to be negative. And so all of the numbers in between negative 1 and 3, all of the x coordinates, when you plug them into here, okay, I want to say that again slowly so you get that. If one of the numbers in between negative 1 and 3 produces a negative overall result, all of them will. So up here, I know that this is going to become negative in that interval. Every value is going to be negative. And just like here, if you pick a number greater than 3, and like the suggestion we have here is 5. 5 plus 1 is 6. That's a positive. 5 minus 3 is 2. That is also a positive. Positive. When you multiply a positive by a positive, you get positive. So every value out there is going to be a positive. The only places where the function goes to 0 was was at negative 1 and at 3. So wherever else it is, I mean, if it's positive once in this interval, it's positive everywhere because no place else does the graph ever go back down through 0. So then with the question is asking, that's what it's saying right here, since the inequality is asking where this thing is less than or equal to 0, we're looking for where this thing is equal to negative values or 0, and that was in between. That was in between the two roots, so we might write it like this. Now, another way you might interpret this, basically doing the exact same thing, everybody, and I mean that, exactly the same thing, but just a little bit more visually, okay, because I like being able to see things. X plus 1, x minus 3. Okay. X plus 1 is going to look like this. X minus 3 is going to look like this. Now, how does that help me? Okay, well, now I can see quite a bit clearer without even doing all that math. Here, both of them are negative. This one's positive, this one's negative. Both of them are positive. So if these lines are both on the same side of the x-axis, then the result's going to be positive. If they're on different sides, the result is going to be negative. That's just a quicker way of doing the whole plus minus thing. And I know that my lines are going to be drawn like this. Okay, this is going right back to Math 10, just because of these little linear functions that I've got here. X plus 1's got a positive 1 slope, positive 1 slope. Anyway, let's do some more problems here. All right, let's see if we can answer this question. X squared minus x minus 12 less than 0. Okay, so the very first thing we're going to do here, just like we did before, we gotta figure out what our x-intercepts here are going to be. This is going to be x plus 3, x minus 4. So negative 3, positive 4. Those are our two key numbers. So we're going to identify those. We're going to put circles around those. Okay? Now, I'm going to draw really quickly these two lines, x plus 3, x minus 4. X plus 3, x minus 4. Now, I don't even want to look at the question right now. I can see over here that any test point that I pick is going to produce a negative and a negative. They're both below, okay, over here, they are both below the x-axis. So a negative and a negative, positive. Same thing over on the other side here, except here they're both positive. Positive and a positive is going to get me a positive. In between the negative 3 and the 4, one of those lines is above, one of them is below. This one's going to be positive, this one's going to be negative, so the overall result is going to be negative. So now I can go back to the question. It's asking me, where is this function less than 0? Well, where do I see the negative popping out here? Well, that's in between. So in between negative 3 and 4. Or if you want to use interval notation, that would be negative 3 and 4 with parentheses around it. Okay? If you wanted to use test points, you just have to pick a number over here. So let's pick a number that's less than negative 3 and plug that in. Let's say negative 4. Negative 4 plus 3 is negative 1. Negative 4 minus 4 is going to be negative 8. Okay, well, they're both negative, producing a positive. And so that's how you'd go about doing that. If you're going to choose in between the two roots, well, notice that this interval goes over 0. I would choose 0 here. So 0 plus 3 is positive, 0 minus 4 is negative, and there it is, the positive and the negative right there. Okay? Let's take a look at another one. So down here we want to look at where negative 3x squared minus 9x plus 30 is less than or equal to 0. Okay, this one is a little tricky here. And I say that because of the negative out front. Okay? So in this case right here, okay, I'll show you what I would do here. Because this is how really crazy lazy I am. They've done the factoring for us. We already know that our x-intercepts are going to be negative 5 and positive 2. Okay? Now, I have already established a method if this is positive and this is positive. I have already established a method for that. What I've done is I'm putting these little circles around the negative 5 and the 2. Because of the or equal to, I am shading those guys in. Okay? And then I'm drawing these little lines right here. That's my first factor. There's my second factor. And I'm drawing my vertical lines because I've got this x less than negative 5. Whoops. Negative 5 less than x less than 2. X is greater than 2. Those are the three intervals that I'm getting here. Oh, the problem is that negative. It wasn't there before. It would be so much easier if this question looked more like the previous one. Oh, I know what I can do. If I take and divide both sides of this equation by negative 3, I'm going to lose the negative 3 on the left-hand side. Now, 0 divided by negative 3 is just going to be 0. But here's the trick, and this is the only thing you got to remember. When you divide by a negative, it changes the direction of the sign. Now I'm looking for something slightly different than it looked like up here. It's still going to give me the same answer. And I can now use my entire setup here. All I got to remember here is, again, this is positive, this is negative, this is positive. I am now interested in where that thing is greater than or equal to 0. And you can see, based on the work that I'm doing here, that that's got to be here. It's going to be where x is less than or equal to negative 5 because of the question. Union, x is greater than or equal to 2. Okay, so that's going to be, if I want to shade that on the number line, looks something like this. Oh, I should have shaded that first question. Sorry. I'll go back and do that right now. If I want to do this in interval notation, that's going to be negative infinity to negative 5, square bracket, union, square bracket 2, out to infinity.
Finally, we'll solve quadratic inequalities with our calculator.
Okay, we're going to take a look at one other method here relatively quickly here. It's just the calculator method. The problem with this one is that it doesn't work to give you always exact values the way you'd like it. It'll give you like a nice general ballpark. If you've got like radical answers in there, like if you're looking for the x-intercepts, you need to use the quadratic formula to get those x-intercepts. This method here is not going to work out great. But what you're going to do here is you're going to go in and actually type the inequality into your calculator in the y equals section. I'll show you how to do that in just a second here. To get the inequalities, you got to use the test button or the test menu on your calculator, and I'll show you where they are in a second. Now, the way that test one works here, the way the calculator interprets that, if the answer to your test is true, the calculator spits out a 1. If it's false, it spits out a 0, and you can use that to determine whether or not you're looking at the right interval. Let's take a look at some examples of that. Okay, so let's take a look at this one. We're going to type this into our calculator and just take a look at the solution. 20 minus x less than or equal to x squared. Now, to enter that in, I'm going to bring everything over, make that x squared plus x minus 20. I'm going to use that to figure out where this thing is essentially less than or equal to 0. So I'm going to move this all over. Okay, I still want the inequality pointed at this expression right here, so less than or equal to 0. If you see it like this, you might have a easier time plugging this in the calculator. So here we go. So I'll press my y equals, and I'm going to enter this in. I'm going to put parentheses around this. I'm going to enter this in. X squared, what did I have there? Plus x minus 20. Okay. So plus x minus 20 in parentheses. And now what I'm going to do is I'm going to go into my test menu, and the word test is right above math. So second, test. And I've got all these options right here. The one that I'm interested in is less than or equal to. So I'm going to go down to number 6. And it drops that less than or equal to. And I'm going to put a 0 in there. Now, when I go to my table of values, notice what it's doing. I've got a bunch of 1s up here and then changes to 0s. Now let's just take a look. 1s means true. So it looks like this goes up to 4. And then the last one that I get to here is that negative 5. So between negative 5 and 4, that appears to be where the calculator is saying that's true. So I'm thinking negative 5 less than or equal to x less than or equal to positive 4. Now, I can double check that real quick that those are actually the factors of negative 20 that are going to add to positive, negative 20, and when I create the factors out of that, those are the factors I'm looking for. But if these were, if the numbers that we're looking for were actually radical values that just happened to be close to those two numbers, the calculator might not be able to tell the difference. So this is a little bit limited in its use. Okay? Let's use it for a couple other questions here. So a golfer hits a ball down the fairway. She would like to know the length of time in seconds that the ball was a height of at least 25 meters. The path of the ball is modeled by, and we're given this function right here, h of x is equal to negative 8t squared plus 40t, where the h is in meters and t is in seconds. So she wants to know the length of time that it's at least that much here. So what we're looking for here is where this function, negative 8t squared plus 40t, is greater than or equal to 25. Okay, well, let's just bring that over. Negative 8t squared plus 40t minus 25 is greater than or equal to 0. Well, let's do it. Go to the calculator. So y equals, let's clear that up. What do we got here? Negative 8 squared, so negative x squared plus 40x minus 25. Oh, I forgot the parentheses. That would cause me a problem because the calculator would interpret it as just being compared to the negative 25. So, and I want that to be greater than or equal to 0. Okay, let's go to our table of values. Okay, well, that looks like it happens at 1 and then stops at 4. Okay, so it looks like this is going to be true from 1 out to 4. Now, is that actually correct? Let's just take a quick look here. Let's go y equals, tell you what, let's drop that bit right there. Delete, delete. Let's graph this. Now, 25 is way up there, so I'm actually going to have to change my window settings so that my y max is a bit bigger than what I had asked for initially. Let's make that 30. There's my graph. Oh, I'm sorry. So I totally misread that. I have already put the 25 in there. I am simply looking for my x-intercepts. So I'm going to go take a quick look at my x-intercepts here, 0. Sorry, I was assuming that I had two separate graphs and I was gonna plot those. So left bound, right bound. See, now that's exactly what I was talking about before. Actually, the x-intercept here is 0.7, 7.3, and so on. My other intercept here, if I go down here, is going to be, go over and down, 4.3. So here's what's happening here. The calculator is giving us the numbers in between. So it's slightly larger than that. So how much time is she above there? It turns out it's a little bit more than that test feature is going to tell you. It's going to be 4.3 seconds. Okay, so like 4.3 seconds minus that 0.7 seconds. So actually she's above about 3.6 seconds there. Okay, that's what that is looking for if you use the, sorry, if you're using the calculator to do that kind of a problem there. Okay, let's take a quick look at this one. On average, a theater sells 2,000 tickets at $10 each. A survey indicates that for each $1 increase, the number of tickets sold decreases by 100. Determine the range of ticket prices that would result in a revenue of at least $15,000. Okay, let's take a look at revenue to start off with. Revenue is going to be the number sold multiplied by cost per unit. Okay, so this is going to be, we can sell 2,000 tickets at $10, but every time we increase that by $1, we're going to lose 100. Now, how many times are we going to increase it by $1? We don't know. So that means we don't know how many times we're going to lose 100 here. We are looking for a revenue of at least 15,000. So I want this to be greater than or equal to 15,000. Okay, well, now to do this question here, maybe what we'll do, again, we'll use our calculator here. I'm going to try this in a slightly different way here, though, just to give you an idea of another way that you can approach this. I'm going to enter these into the calculator in two different y equals. So this first one I'm going to enter in, okay, so 2,000 minus 100x, that's multiplied by 10 plus x. Okay, 10 plus x. And then in the second line here, I'm going to enter in the 15,000. It's just another way of doing this same problem here. Now, when I press graph, I am not going to see what I need to see because my window settings aren't anywhere near what they need to be in order to see this. So what I'm going to do here is I'm going to change my window settings. Now, first of all, because X is going to refer to the number of ticket price increases, it doesn't make sense to talk about negative X. So I'm going to get rid of that. And then additionally, because I'm talking about values of greater than 15,000, my Y max needs to be greater than 15,000. Let's put 20,000 in there. See what happens when we graph it. Okay, so now when I press graph, I'm getting that right there, and I'm not seeing the parabola here. So okay, so something's up with my window settings. So let's go back to my window here. Well, maybe it's my X max. Maybe I need to make that bigger. Let's make that 30 and see what happens. Okay, there's my parabola coming down. Okay, so now I'm missing a part of the graph over here. So maybe it is the case that my X value is negative. Now, that would mean in this context of this problem that what's going on here is the ticket prices are maybe overpriced and they need to come down a little bit. At least that's what that would imply there. Okay, there's my parabola. Good. So I see it going up and coming down. So it's going across here. So the question is asking, where is the parabola larger than 15,000? Well, it hits 15,000 right there. So let's take a quick look. So I'm going to look for the intersection, and I just need to move my cursor close to this point of intersection here. Enter, enter, enter. And I see negative 3.66. So negative 3.66 less than or equal to X, less than or equal to, let's go back to my point of intersection. Let's come over here, move that way over, move that way over to here. And we get 13.66. Whoops. So determine the range of ticket prices that would result in a revenue of at least 15,000. Okay, so we are increasing. If we let our number of increases become negative, essentially what we're doing here is we've got $10 minus 3.66. So from $6.34, we're going to get 15,000. And now if we add $13.66, so we have 10 plus 13.66, $23.66. So ticket prices in between $6.34 and $23.66, those will give me a profit or a revenue of larger than 15,000. The nice thing about doing it that way is you really do get to see it go over that value. Anyway, I hope that made sense. Sorry about the video cutting in and out. That's because there was announcements that kept coming on while I was videoing.